Welcome back, everyone. I hope that you had a fantastic working session and are making progress on your ideas. We've seen many of you take part in networking sessions earlier, asking a lot of questions to your mentors and all of the little people helping you out with the hackathon. I hope that you're going to be keeping to do more of that later today. But now I'm excited to introduce you to our next panel discussion on water management, who's going to be moderated by Emre, R&D Director at Arçelik, the parent company of Beko. The discussion will be on one of the most pressing issues of our time on how businesses can play a part in tackling this challenge. Emre, how are you?
I'm very, very good. Thank you, Sebastian, and I hope you're fine as well.
Absolutely. Thank you. We're very excited here in the studio to have you guys have this exciting discussion, and we'll be following it with all of your panelists. So without further ado, I will let you introduce them and wish you a fantastic session, and we'll come back at 3 once you're done with everyone.
Okay, dear guests, dear attendees, welcome to our panel. We are very excited to be here, and it's a pleasure to meet you all on a very, very fine, lovely Saturday. So actually, similar to our previous sessions, we want to inspire and encourage all our participants on this very challenging issue. We have 3 panelists. Franz Besnik, he's R&D Director and Global Head R&D Sustainability at Procter & Gamble. Hello, Franz.
Hi, everybody.
And we have Ansi Mikola. He is the CEO of Rivercycle. Very pleased to have you on board, Ansi.
Thank you. Thank you for having. Looking forward to a very exciting discussion.
And lastly, we have Dr. Natalie Velden. She's a lecturer in environmental science and sustainability at the University of Glasgow. Welcome, Natalie.
Hi, everyone. It's really nice to be here.
Okay, actually, as most of our participants know, and the world knows, actually, the unsustainable growing demands and the increasing population, it has a huge pressure on the water supplies we have. And as you know, only 1% of Earth's water is usable as fresh water. So we are predicting that actually we are having now some crisis for accessing fresh water in the coming future, and that will threaten the regional stability of our world. So actually, it's not only our problem, because as we know, 60%, 70% of human bodies are water. So it's very important for us as human beings, but it's also important for the ecosystem as well, because unfortunately, the water pollution in rivers, lakes, ocean, they pose a huge threat to our ecosystem. So within this panel, we would like to discuss how we can fight this, how we can mitigate as the businesses, as academy, and as the consumers, of course. And so I would like to first turn back to the manufacturing, because as we know, manufacturing facilities, manufacturing processes use a lot of water. And actually 1/5, almost 20% of global water withdrawals are dedicated to industrial uses. So as businesses, I would like to turn to Franz. What can businesses do to drive water efficiency holistically?
Thank you, Emre. Let me just start with introducing myself by saying that in 4 words, that's my mission, and that's the provocation for every one of you brainstorming new solutions. I like to say that I'm in the business to make sustainable irresistible. That's my job, that's my obsession, and that's the invitation for today's brainstorming. Make it irresistible in a way where any stakeholder, any producer, any consumer, any citizen in the world which will rush to these solutions, not because they're sustainable, because today that's not necessarily the priority, but because they are absolutely irresistible. And they will be made sustainable so that they can rush like there's no tomorrow to these solutions in the face of that climate emergency. Having said that, so that's kind of the preface of everything that I want to be talking here. Let me just share a few slides of our programs in P&G. And we'll go, as you're inviting us, Emre, I'll start with the production, and I will certainly talk about the homes. Hopefully you can see that. And that's P&G at a glance. We are providing products in the bathrooms to shave face, to wash hands, to wash hair. We are in laundry rooms. We wash dishes in the kitchens. We wash kitchens. We wash floors in living space. In fact, 70% of our products are using water. Use water, and not only inside the formulas and components, but also in the homes. So we are a water processing and cleaning company, as a matter of fact. Before we clean the hair of people, we clean the water that cleans the air. Before we clean the laundry, we clean the water that cleans the laundry. And we are in the homes of 5 billion consumers. So it gives us a lot of responsibility and a ton of volumes of water to deal with. So how does it play? Well, first, we're really centering on priority basins. Reducing water at the manufacturing sites is interesting, but it's only interesting to us if it's actually going to do something positive on the priority basins we are in. And so we've done a massive study across all our global manufacturing sites in the place they are, as well as our consumers, and defined 18 priority basins in 7 countries where we actually are doing actions. And we are working with partners to ultimately enable those restoration. And that starts obviously by reducing water in our operations. You see here, a global map with these 18 dots that represents those priority basins. And what we're committing to is to use 35% less water per unit of production. And that's versus 2010. And right now, on the year of 2022, we're at 25. So we're doing great progress. And of course, we still have 10 points to achieve. And these are probably the most difficult, but there's a lot of progress there. And we are sourcing 5 billion liters of circular sources, and we're about 3 right now versus the 5 for 2030. In fact, we're just off of a hackathon. We also organized ourselves in our German sites in Kronberg with 3 big challenges on water in manufacturing area. So I'm not going to go into details, but we are actually very interested in solutions. So you can see the title of the solutions and the thematics for whomever is actually close to this type of problems. Now, moving on to besides the sites, we are also caring about communities in need. And since 2004, we've actually provided 18 billion clean drinking water to communities in need. And we're committing to 25 billion by 2025. And what is it? This is what we're talking about. A technology, literally a sachet, which is a treatment plant, water plant, in the form of 10-gram sachet that cleans 10 liters of water in 10 minutes. Literally, you take pond water and you're going to turn it into 10 liters of clean drinking water. And that's really important, of course, for those communities that don't have access to clean drinking water, or communities that just face the climate disasters, and don't have access to clean drinking water. So that's the type of cleaning technology, water cleaning technologies that we can put in place to actually enable those fast transformations from dirty to clean water in 10 minutes. And last but not least, and that's 90+% of the water use across all I've been talking about, is the one that people, consumers and citizens around the world are using in their homes. And that's the commitment we're making of creating by 2030, helping 1 billion people with access to water efficient products, but even more, more expensively and systematically, how we totally reinvent our homes of tomorrow. What about, how about we're going to make homes that run at 50 liters per day per person, when today the average in Europe is about 180 to 100, down to 50 liters per day per person, yet it feels like 500 liters. Let me just go a little more in details. Well, I told you that I like to make sustainable irresistible. Well, actually, the one thing that is irresistible for me in the morning, it's taking a shower. Refresh myself, clean myself, refreshing myself, getting ready for the day. And yet, a 7-minute shower, which I take every day at 7 liters a minute, is actually a 50-liter shower right there. I didn't know I was using so much water for my first 7 minutes in the day, and I got shocked. Now, the other side of that, thinking holistically, is what's the greenhouse gas? Because at the end of the day, I'm also using heating, and heating is carbon. So here's a question, and I start to ask myself while showering. Well, what is it that impacts most that my greenhouse gas of me showering every morning in that 7 minutes? I know now I'm spending 50 liters, but how much greenhouse gas? How big is that? And what's coming? What's actually impacting that? Is it ingredients of the soap I'm using? Is it the packaging? Is it the manufacturing? Is it the manufacturing of that body soap? We talk about manufacturing. Is it the transportation from the manufacturing sites to retail stores to home? Is it the hot water I use during showering, these 50 liters? Or is it the waste of recycling that water or the packaging? That's what people reply to me. Oh, it's got to be 80% is about, it's coming from the manufacturing of that product, and 20% is coming from the transportation, from plants to distribution centers to retail home. Well, that's the reality. 95% of the greenhouse gas of me and you showering every morning, for those that have affluent water at home, is coming from the hot water I use. Then 1% is from the ingredients, 1% is from the packaging, 1% is from the manufacturing, 1% is from the transportation, and 1% is from the recycling. So the water in the homes is actually a big greenhouse gas hotspot, because it's actually true. What I've shown on showering is absolutely true on hand dishing. When I do hand dish at the kitchen faucet every day, twice a day, as a matter of fact, 90% of my greenhouse gas of me hand dishing at the kitchen faucet is coming from the amount of hot water I use. And then 2% ish comes from the rest, the product I use, the packaging, the manufacturing, the transportation, and the waste. Floor cleaning, filling up a floor, a bucket with hot water to clean my floor, same story. Laundering is somewhat a little less at 70%, but still 70% is coming from the hot water I use, because people like to use 40 or 50 or even more to wash clothes. And then, of course, you've got a more marginal impact from the other ingredients. So hot water is not only you've got a water scarcity to address, but there's actually a greenhouse gas huge opportunity to address. In fact, if you look at the left-hand side at our homes, the first contributor of greenhouse gas is the space heating, is heating our homes. But the second is actually heating all this water that I've talked about. And in fact, if 20 to 25% of the contribution is coming from water heating, and the built environment is 40% of the total global emissions, what we're talking about here is the equivalent of the airline industry in the form of hot water, water heating in our homes. That's a massive impact. Unknown, hidden, nobody knows I didn't know, and no, I know, and I'm telling you. So what do we do about that? So how about we're gonna, in the face of water scarcity and that greenhouse gas emergency we've got to resolve, how about we shift a paradigm from how do we make people live down to 50 liters per day per person, to how we make homes at 50 liters that feel like 500 liters. And how we do that, instead of telling people, oh my God, let's take short, cold showers. Why not? Start showers. How about we take the water that we use and we recycle it? We purify in situ and recycle it, so that I can endlessly take a shower with the same water, but it keeps being purified. And not only I'm conserving the water, but I'm conserving the heat of the water. So I'm solving both problems. Indeed, why are we throwing or flushing our toilets with mineral water? Can I not reuse the water from one of the homes and to flush the toilets versus fresh water? Why is soapy water coming from my shower actually, or from the laundry water, is actually going straight into strawages? Why is that? Is there not a better usage for that? So that's the 50 liter umbrella and the pillars that we're exploring. One really is about, how do we get there? It's really about reducing the amount of hot water we use through water in energy efficient products, water and energy efficient appliances. Where can we remove water? For example, Swiffer is actually not skipping the mop and bucket into a touch-up clean without water at all. And where can I reuse the water, as I just mentioned and hinted, as a new space of innovation where we actually are going to be recycling, creating circular water within the homes. So that's the schematic. It's all open for now. It's about thinking about where we can reduce, reuse, or remove water so that we can get there in a way that feels like 500 liters. So let me just give last couple of examples on how does it play out. I told you about hand dishing. What actually auto dishing is a much better way to save water and energy than hand dish, and that's a big campaign we're running with our main brand in the US called Cascade, where we actually are nudging people that own dishwasher for the most but don't use it to really get, to save the 4 gallons every 2 minutes they run that tap, whilst the dishwasher will run those 4 gallons as a total cycle. On aerial, how do we turn down? I talked to you about water, but also about the heat of the water. How will it turn down to cold washing, so we really can get to no greenhouse gas emission whilst laundering our clothes? And guess what? As we do that, not only we turn down the greenhouse gas emission dramatically, but we also improve garment longevity and reduce the microfibers that actually end up into water, killing 3 birds with 1 stone: the water, the greenhouse gas, and the problem, a serious problem of water pollution caused by microfibers. Last but not least, how do we think about next generation cleaning, where we also remove all the water from the product, and we actually pack things away from plastics that end up also in rivers, into cartons that we can recycle, very dry, a little swatch, very compacted swatch, fibers-based, natural-based technology that that you can actually clean your hands, your shampoo, or clean your laundry all together at cold washing, and now killing all birds, hopefully with 1 stone, so as many birds as possible, with 1 stone. So that's the dream we're after. You are welcome to help us on that, and let's all make sustainable irresistible. Thank you.
Okay, thank you very much, Franz, for this very interesting and inspiring presentation. Actually, well, just looking at my notes, the motto "irresistible" is quite catchy. Thank you for letting us know this motto. And the numbers, when I look at the numbers, you said 70% of your products use water. You are in 5 billion consumers. You are with 5 billion consumers. Such a huge impact. We have a potential to make such a huge impact. And also you described an ecosystem ranging from the greenhouse gas emissions related to water and recycling of water at home. It's actually a great ecosystem. Thank you for this very nice presentation. Actually, going to the manufacturing side for Arçelik, as the home appliances manufacturer, we also have a huge responsibility for this, because we know that globally 80% of the wastewater is unfortunately still released into the environment without filtration or without a chance to be reused. But during the last couple of years, actually for the last 12 years, with filtration technologies, rainwater harvesting projects, and water efficiency projects, we are proud to say that we saved over 2 million tons of water during our production processes, which is actually a huge amount. As we have been discussing with Franz, as he mentioned, reducing the water consumption of homes down to 50 liters per person, it's really challenging. This number is equivalent to the daily water consumption of approximately 3 million households per day. So it's really important. So now I would like to turn back to another issue. Water efficiency is one of the major problems, major topics we have to discuss. But there is another problem, plastic pollution, actually, because we know that over 100 million marine animals die from plastic waste every year, because 14 million tons of the plastics, which is in total around 300 million tons, manufactured in different applications, in different products globally, 3 million tons of plastics each year. 40 million of this reach to the oceans. So they say that this is something really interesting. If you like having fish for dinner too much, you eat as much plastic as a credit card during 1 year, unfortunately, because these plastics, microfibers especially, go into the ecosystem and then to the food chain, and it's a huge threat for humans and the wildlife ecosystem. So I would like to turn back to Ansi. So Ansi, ways do we have? What alternative ways do we have to tackle this plastic pollution?
I'm sorry, there was a little cut in the connection, but so I may present, correct?
Yes, the floor is yours.
Thanks, Emre. Thanks, Emre. So a little introduction of who am I. I'm Anssi Mikola, and I'm a shipbuilding engineer by education, serial entrepreneur by profession, and I suffer of something that I think the hackathon members probably suffer as well. You just haven't named it. It's called the bubbling mind syndrome. The way it works is whenever there's a little bit of free time, my brain starts solving the last problem that it has seen. And you can't do anything about it. You just keep bubbling with all kinds of solutions to different kinds of problems. And what happened to me in 2018 was that I went to bed after having read about the plastic pollution, especially the part that's going through rivers into the ocean. And then in the morning, I woke up and I had invented a river cleaner. And I thought, this is it. Now I've kind of hacked the problem. All we need to do is just put all the rivers, equip them with a river cleaner, and there'll be no more plastic in the oceans. And it didn't go like that. So where we are at the moment is we're not in the business of selling river cleaners. We are in the business of selling river cleaning as a free service. And the reason we do that is when you look at the value chain of goods that are packed in plastic. In the West, in developed countries, the system is divided between basically two players. You have the producers who cut the cost of production, packaging, transportation. Of course, ultimately, it's the consumer who pays for all of it at the end of the day. But that's the part that's traditionally belonged to the manufacturers. And then we have this social contract that it's the municipalities, the state, that takes care of the waste. So we're free to dispose the plastic packaging, and it's collected, and everything works fine. Now, unfortunately, when you take this ecosystem or this value chain into a developing country, then what happens is there is basically very little money for waste management. Somebody once told me that if we wanted to pay for Western kind of waste management in poor developing countries, they would need to increase their municipal taxes by 15%. And I don't mean if it's 20% now, you increase it by 15. It's just you go from 0 to 15%. And I think everybody can understand that that is not politically possible. Nobody will get elected with a slogan of, we shall stop marine pollution from our country by increasing our taxes by 15%. So we're in a situation where basically producers, manufacturers are kind of tied within their global system of production, packaging, transportation, and that's where it ends. And unfortunately, the plastic packaging is then and ends up, first of all, being picked more or less like we do in the West. You collect and then you pick the valuables, the PET bottles, the metals, and so on, and you recycle them. The rest in the West gets normally incinerated. But in a developing country, it's actually quite the opposite. It does get picked even better than it does in the West. But then after that, what do you do with the rest? Now, in a situation where there's no waste management, you basically have two wonderful choices if you're living by a river. You can either throw the waste on your front yard, let's say within 30 minutes, you will have rats. After that will come the dogs. So you will have a horrible scene on your front yard. Or the other choice, throw it over the back, which is where the river is. And out of sight, out of mind, clear. So at that point then, we've come to the situation where the waste is in the river. And that's a wonderful place because everybody has a veto on being responsible for waste in the river. If it's the Waterway Authority, their reply is that it's in the law, waste is the responsibility of the municipality. The municipalities tend to think that, well, first of all, it's coming from upstream. It's not just us. If you have a long 100-kilometer river, there would be tens of municipalities along the river. So why should the last one at the river mouth be responsible for it? And then you have technology suppliers, such as we were at the point of having invented a river cleaner. And nobody wants to buy a river cleaner. I mean, we were literally told, get out of here, go away, and stay away. Because if you do lift waste from the river, then there it's nobody's problem. But the moment it's on land, then it is somebody's problem. Whoever owns the land is responsible for it. So what are you going to do about it? If your only solution is to take it to a landfill, then looking at places like city of Jakarta, what can they do with it? They can take it to a place called Bantar Gebang, one of the largest landfills in the world, which is a wonderful place. First of all, it's been illegal for more than 10 years. It's very full and it's very far away. So if you do clean a river, you end up paying hundreds and hundreds of thousands of euros every year just to take it to the landfill. Then you have development banks who have billions and billions of money, but nobody's asking for it because a bank is a bank. You need to pay it back one day. Why would somebody invest in a river cleaner when all you get is expenses? Why do you want to make an investment that only increases your expenses? So it doesn't work. It's a autocracy that stops everything. And how do you solve that then? You take a look at the situation where they do not have the money. So instead of selling river cleaners, we started selling river cleaning as a free service. Now it sells a whole lot better. Rather than saying, why don't you buy a river cleaner? We say, would you mind if we clean your river for free? And as long as you can say that you clean the river for free and you take care of all the waste, and actually in our case, we also take care of the waste that's already at your landfill, then it's a much better proposition because the landfill, as you remember, is full. So, and it's getting more full. So what we do is we first clean the river, then we take the additional feedstock from the stream that's going into the landfill. So we take out the low-value plastics from the feed going into the landfill. We put it into technology called pyrolysis, which is basically putting plastic in a pan, taking the oxygen out, heating it, and it turns into oil, which can then be processed further on to go back to plastics. So this way, we're landfill volume negative. We don't charge the municipality. So everybody's happy. We're actually getting some permits to clean rivers, because getting a river cleaning permit, I can tell you, our first one took 13 months before somebody actually agreed that we can come and clean it for free. The next ones have been faster. But that's not the final goal of the thing. The final goal is that once we have the pyrolysis there, so we can create extra value for the low value plastics, then at that point, we can set up segregating collection points along the river. So now the guy who is thinking whether to get the rats or the river actually has a choice of giving the plastic away and we're us taking all of the waste, and that way we can collect it before it goes to the river. And within what Sir David Attenborough calls an ecological glimpse of an eye, we expect there to be absolutely no plastic in the rivers ever again. The glimpse of an eye in ecological terms is something in excess of 50 years, and then we should be done. Now, how does it look in practice? We have a video. Can we share the video? So this is our site in Mumbai. This is a tidal river. This is what we catch twice a day, about 3 to 7 tons of floating waste. Since it's tidal, it changes level by 4.5 meters every once in a while. So we need a fairly high conveyor belt to take it up. And what we get is pretty much everything. It's biofractions, packaging, water lilies, you name it. So we catch it, we sort it. These are the low-value plastics, which is what most of the plastic there is. If it was valuable, it would have been taken out. Then we take it to shredding so that we can feed it into the pyro machine. It has the preheater, the actual reactor on the left. This one takes about 7 tons of low-value plastic waste per day. It's turned into oil, which is then sold. We have our own lab where we test what actually came out, because obviously garbage in, garbage out. If you don't test what came out, you don't know how you can use the oil. And that's what it looks like in practice. A very simple thing to do. And where we are at the moment, 2018, I woke up with the idea of a river cleaner. Now we're in 5 places around the world, funded by the likes of Coca-Cola, Benioff Ocean Initiative, UK Aid, DMDP, which is the Danish Foreign Ministry. And the goal that we've set for ourselves is that within the next 8 years, we need about 2.5 billion euros, out of which 90% goes into the recycling infrastructure, 10% into the river cleaners. With that, we're able to catch about 3 million tons, or catch and recycle 3 million tons a year of low-value plastics, which is about 75% of the current estimate of how much goes into the ocean through the rivers. And then the world will be ready. At that point, the turnover is about 1 billion, and it's a machine that produces 350 million euros a year of basically foreign aid or development aid, because it goes to who used to be waste pickers, who are running the recycling system. And then the world is ready, and there will be no more plastic in the rivers. Now, from the point of view of the hackathon, I think the one thing that really has come as a surprise kind of to us is that it was never a technical problem. It's a socio-economic problem. A part of the value chain is missing, and you cannot expect people to pay 15% extra taxes in order to deal with ocean plastic problem. Okay, you will deal with the whole plastic problem, but anyway. So we need to do something else. So what we find still unique in our solution is that we seem to be the only company in the world at the moment who's combining.
Okay, I think we have, Anssi has a connection problem. Can you hear us, Anssi?
Yeah, there was a small short connection. Anyway, so what I was, hopefully you still heard that what we find unique in our solution is that we are the only company who combines the ecological activity of cleaning the river with making money out of the recycling. So we're kind of taking the missing parts of the ecosystem and turning that into an environmental solution.
Yes, thank you. Thank you very much, Anssi, for this very interesting presentation, and actually having us another concept is bubbling mind syndrome. Actually, I heard it for the first time. Thank you for sharing this syndrome with us. And as you mentioned, some problems are really everybody's problem, but nobody's responsibility. So what you are trying here to bring different shareholders together, collaborate. Collaboration seems to be an important aspect to tackle some of these problems we have, I think. So thank you for this lovely presentation. And actually plastics, I mean large plastics, let's say, are not the only problem for the oceans, because today we know that almost 33% of the synthetic microfibers come from microplastics that we use wash our clothes at home, and so these microfibers are shed from our clothes going into the oceans. So now turning the conversation to this problem, I would like to turn to Dr. Natalie Velden. So what is this microfiber pollution, and how is it related to our businesses? What do you think?
That's a really big question, and it's a real hold my beer moment for me, because this is about 12 years or about a third of my life that have been spent around and into this issue. So for context, guys, I'm here as a researcher in environmental pollution and ecotoxicology. So basically studying what substances go into the environment and the secondary mess that they make when they get there. So my work in relation to microplastics includes their sources and their impact on things like food provision, as well as how we might mitigate and reduce any effects that they have. So as we've already heard, there are numerous sources of plastic into aquatic environments due to the scale of their use globally. And they've got recalcitrant properties and relatively low density, which allows them to be able to be transported for long distances and build up to incredibly high levels in the environment. And these plastics can turn up almost anywhere, especially when in marine systems. So as already indicated by Ansi, plastics entering our rivers are carried with the flow and then down into estuarine and marine environments, occasionally being caught up by vegetation, sediments, man-made structures, as well as collectors, hopefully. And in these marine systems, suddenly the movement of these plastics becomes a lot more complex, with floating plastics being affected by wind, waves, and currents, as well as the effects of organisms, which can carry them all around the globe, really. And once they've come to a stop, the plastics themselves may persist for long periods within environments or ecosystems or organisms as well, enabling them to build up over a long time in susceptible locations and in susceptible animals too. Now, while those plastics and the plastic debris, large macroplastic debris, is known to persist for long periods, due to its resistance of the polymers to degradation, the items themselves are still able to fragment down, so gradually reducing in size and increasing in abundance. So 1 becomes 2, 2 becomes 4, to produce another form of debris, which is known as microplastics. Although there's debate over the exact terminology, microplastics are typically classed as those particles that measure measuring less than 5 millimeters in their longest axis. And they may be manufactured in this size, making them primary microplastics, or they may be reduced down to this scale by weathering and wear, making them secondary microplastics. Now, the size and abundance of these microplastics make them available to a range of organisms that might not otherwise be affected by large plastic debris. It's the difference between trying to swallow a football or trying to swallow a marble. One is a lot easier than the other. And the ingestion of these microplastics has been seen to negatively affect some species. And I will come back to this later. The microplastics as well are more easily integrated into substrates such as marine sediments, and here they can affect key abiotic processes, so non-organic processes such as the transmission of heat. And obviously, The microplastics that we observe in environmental samples and studied organisms come in many different forms. And, as has been indicated, some of the most regularly observed are fibers, which in my samples can represent over 90% of the recovered microplastics by abundance. So we're not talking weight. These fibers are really thin. They've got not a lot of depth and width, but they are there a lot in abundance. Now, there are a lot of places where these fibers could come from. We use man-made fibers in a range of industrial and domestic activities, some of which, like the use of synthetic fishing nets, are obvious direct sources of fibers into the marine environment. However, the scale of these sources is comparatively small, and the fishermen in the Clyde Sea, where I've done a lot of work, would be having to use some particularly funky coloured nets to be generating the types of fibres that I find on a monthly basis. On the other hand, as has already been indicated, the use of washing of clothes and their use and wear represents a comparatively enormous pool of synthetic fibers. And as we're increasingly aware, one of the reasons that fibers are so prolific in the environment is the way in which we use and maintain our clothing. Domestic laundry provides a direct route between the textiles in our homes and into wastewater systems, and from there into the environment. And using estimates of microfiber loss during washing as a percentage of the original textile weight, we can attempt to assess the annual weight of fibres that are produced in the UK as a result of the laundry and tumble drying processes, as well as those related to commercial laundry. As you can see on screen, we're into the hundreds of tons of fibres being produced. Fortunately for us, however, our existing water treatment processes are pretty good at capturing microplastics, particularly fibres, in transit. And I've just pulled out an example by Fionn Murphy and colleagues that looked at wastewater treatment in the Clyde, because I'm biased. And you can see that high levels, even at primary treatment and screening, that can be stored by individual wastewater plants. However, even though we're really good at capturing fibres, the annual outputs of domestic wastewater from treatment plants are so large in scale that many millions of fibres can be lost from a single site. And just look at how many wastewater facilities we have in the Clyde Sea alone. So while we can reduce down our microplastic fibre output through wastewater, tons are still lost annually, and the fibres that are retained during wastewater treatment may still make their way to the environment via secondary handling of the sewage sludges, delicious word, which are produced during the treatment process. So it is no surprise that we have a problem with microfiber pollution, particularly in nearshore coastal areas. And as a result of this proliferation, susceptible animals, those with the right mix of diet, feeding strategy, so the way you get your food, and internal body structures, may accumulate high levels of these microplastic fibers. So this has been observed previously in my own work, particularly in places like the Clyde, and I can show you comparisons with elsewhere if you're really interested, in things like fish and shellfish. Those animals that have complex gut structures with lots of hard parts and narrow junctions, such as crabs and lobsters, for example, my lovely langoustine, are at increased risk of aggregating high levels of plastic, whereas animals with simple tube-like guts, so us, some fish species, are generally at lower risk. However, in these vulnerable groups, in these vulnerable species, aggregations of plastics in the gut can result in lower food consumption, as can be seen by the middle graph on screen, and also reductions in things like body mass, nutrient availability, and survivorship, so mortality in your species too. Rubbish for an organism, and highly concerning for any secondary industries, such as our fishing industry, that are dependent on them. Luckily for me as a researcher, microplastic pollution and its various subcategories are firmly in the public eye, and there has been substantial political and public appetite for information on both the problem of microplastics and potential solutions to the issue. Over the past few years, we've been keyed into awareness raising, citizen science and policy progress, and as well as the development of alternative materials and fibre capture. However, whilst there is an increasing interest in problem solving, we're somewhat out over our skis when it comes to the suitability of and apparent success of many of these responses. For example, if we look back at macroplastics, we still have questionable understanding of how the move from single-use carrier bags to reusable or fabric bags has affected the use of multiple essential resources, such as those of natural fibers or potential influences in land use conflicts. Similarly, our response here, as we've already said, and I loved the word holistic earlier, thank you very much, France, our response can't just be about those inputs of fibres. It's about the quality and availability of water in general. And pollution isn't the only problem that we've got to be considering. While we're focusing on a few key issues in water management during today's sessions, it's important to look at that water use from that holistic perspective. Globally, 10% of the world's population, approximately 780 million individuals, live in water-stressed areas, which are regions or countries that use more than 25% of their available water resources. And these are kind of spread some of the areas that you'd expect, however, often arising due to high levels of urbanization or centers of population. So have a look. Potentially you already live at one of these sites and might be affected. Additionally, we extract about 17% of our global renewable water resources, either from surface waters or groundwater, and increasingly from desalination. This water can be used either directly by the consumer in the ways that we've heard today, or indirectly in power generation, or predominantly things like agriculture as well. So industry, power generation, agriculture. And we call this water typically embedded water. So that is not returned to the environment, but one that becomes integral to the product or the service itself. One of the key things that we might forget as designers or consumers is that when we develop or we buy a product, we are also embedding or entraining the water it costs to make it. And when we import food and goods from already water-stressed areas, what we're really doing is exporting our drought. So when we look to identify solutions to whether it's the impact of microfiber pollution or something else, it is really important to ensure that we are not doing more harm than good. So to end, I've given you a few questions to keep in mind regarding our influence on water quality, whether we're creating more waste than we capture, and whether there is a framework in place to accept that waste that we're able to take from the environment. And because I don't have the answers here, I'm good at finding out how many plastics are in things and establishing out what happens when they're there. So as far as I'm concerned, the next bit is pretty much up to you. Thank you for your time today. I know we're a little bit over the session length, so if you do have any questions for me, you can find me on Twitter, and you can direct any other questions that you might have to everyone else, just in case I've run over my slot. But that's me. Thanks so much for listening.
Thank you, Natalie, for this inspiring presentation. Actually, I didn't know that the movement of these microplastics was this much complex in the oceans. So it's really inspiring for us. And I also didn't think about the resistance of polymers to degradation before, because they will last in the oceans for years and years and years unless we can find a good solution for this problem. So actually you mentioned on two different sources, one of them being the synthetic fishing nets and the other being the clothes we are wearing. So we are also let us be a little bit proud to have this world's first integrated fiber catcher washing machine as Arçelik, because we developed this technology, and it's actually now an open innovation. We share all our intellectual property with other manufacturers who are interested in manufacturing such washing machines, where there is a spatial filtering system which catches almost 90% of the synthetic microfibers. So hopefully we will all together solve this problem in the coming years, I guess. So we took the liberty for 5 more minutes, I guess, because we have some questions from our attendees. The first question is to Franz. What are other sustainability-related issues that PMG focus on? Franz?
In 2 seconds, because time is running, we've got 4 big pillars. Water, we talked it today. Energy, related to water, I talked it today. Waste, I hinted today, because waste is also part of the water, but its own issues on its own. And then nature-based solutions. So these are the 4 pillars, and these would cut across supply chain entirely, from our manufacturing, our own production sites, and our own products, manufacturing sites, all the way to consumer homes. So that's probably the most simple way I could answer that large question.
Okay, thank you, Franz. And the next question is to Ansi. What do you suggest to entrepreneurs? Well, it's a good question. What do you suggest to entrepreneurs to scale their business?
I think since we are basically working in developing countries, my suggestion is these are countries where you need to sell your product and give the money with which the customer pays for the product. So you better come with the money. Get the money with which the customer is going to buy your product.
Okay, thank you for this advice to our attendees. And let's take one more question. This is for Natalie. What will be the potential results of the microplastics issue in the next few decades? Wow.
It's an extensive question. I think it depends on how eager people are to work together. As might have been indicated in some of the slides, I've been involved in different working groups around changing public policy and the design of new materials, for example. However, it's getting people out of their silos. This has a potential to be a really transformative issue in that it is a pollution problem that has very much a public focus to it as well as an industry focus. I'm so used to things like DDT or mercury that are just 2 or 3 steps removed from the consumer. It's not something they can actually control in any way. If we can leverage some of that goodwill, if we can make sure that any implications or the work is done industry-wide, we have the potential to make really great gains, not just in terms of fibers and microplastics, but in the way that we address a lot of environmental issues. In terms of if we don't do much, it's really hard to tell. I mean, there's such biodiversity out there globally that it's really hard to predict how our increasing levels of plastics and microplastics in the marine environment will continue to affect things like food availability, things like the abiotic processes in marine environments, and yes, as well, our health in the long run, although there's still a lot to do until we can understand the extent of any negative impacts there. So that's kind of why I'm here, to be honest, to make sure that we take the proactive path rather than the negative one.
Thank you, Natalie. So I think it's been a very inspiring session, and we discussed many different aspects of the water problem, starting from manufacturing to decreasing the water consumption at households per person, then cleaning rivers with new business models and collaborations, and the effect of microfiber pollution to the marine ecosystems and for different species. So I hope our attendees liked the session and found it inspiring to come up with new solutions to this huge problem. I would like to thank you once again for your participation. Thank you.
Thank you so much
for having
us. Bye, everybody.
Nice to be here.
Thank you again. Take good care.
Bye-bye.
Yep.
Thank you very much, Enri, and thank you to all of our panelists. Very interesting discussion. Now it's time for our workshop for all of the participating teams to move forward. And the workshop is going to be focused on MVP and how to actually approach building out your product and then testing it. So for all the participating teams, please now will be a good time for you to head over to the learning stage to listen to Louis from the TNW team, who's going to be talking to you about MVP and building out the product. For all our other attendees, it will be good for you to join us back here on the Inspiration stage at 4 p.m. UK time for a panel discussion on climate change. So enjoy the workshop, and for all of you, I will see you back here at 4 p.m. UK time.